Alright, welcome back to the 3ds Max SDK training. This is Unit 5, Day 5. So today we're going to be talking about the parameter blocks and also the function publishing system. So before we get started, I'd like to switch over and show the example code from yesterday. So it was about the reference system, and the first parts was just to review the documentation. Hopefully you found that okay. And the rest of it was to actually implement a reference system. So basically implement a reference maker and make references to the selected node and then report changes to that selected node. Okay, so I have the exercise 4 code loaded into Visual Studio and I'm actually running it at the moment. The first thing you needed to do was to add the reference maker support. So you had to add inheritance for that. And then we need to support the reference maker functionality. So here's the number of refs, get reference, set reference, notify ref changed. So I've got some breakpoints set in all of these. So let's just switch over to Max and run this. So I'll go into the utilities. There's exercise 4, okay. And you'll see the first thing it does is it hits my constructor. What do we do in the constructor? We need to initialize the reference to null. Okay, and this is the node that we're making a reference to, and it is also a member of our class as a private member variable. So it's always important to initialize it to null. So if I go ahead and continue running this, you're going to see it hits the begin edit params, and this is the initialization for the utility object. And the first thing we'll do is we'll check the selection set to see if we have something, and if we do, we'll go ahead and make a reference to that node. Alright, so we call replace reference, our index for the reference, which is 0 because we only have one, and then we call, we actually get the node from the selection set. Alright, so we call that, and then what it does first is it starts by calling the reference system implementations. So first thing it's going to do is say the number of references, return 1. Let's run that. And then notice what it does is it calls get reference first. And in this case, the node is null. So if it wasn't null, we could have a problem. And this is why you need to initialize it, just to be safe. If this was pointing to garbage, it could be a problem. The compilers are now supposed to initialize things to null, but I've seen them not do it. So it's still important and good programming practice to initialize things to null. So let's go ahead and run this again. It's going to hit these again, and then I get my set reference. So the set reference is being called in response to the replace reference that we made up here. So this is the first opportunity that we have to actually set up the reference. So we get passed in the target, and we can basically handle that. So we check to see if it is in fact a node, because that's our type. And if it is, then we can go ahead and assign that target, which was dynamically cast to an inode as temp. And there's temp, and we assigned it to the node. Okay? And then the other supporting things are going to be called from time to time, and it's just the calling sequence that Max has. So now we've got our reference made, and this is the node that we're tracking within the selection set. So let's say something changes. So what I'm going to do is I'm just going to click, let's do the scale. Okay? So I haven't changed it yet. I've just turned on the scale operation. As soon as I click and start to do something, it's going to hit my notify ref changed. Okay? So the first thing you need to do is double check to make sure that the target being passed in is in fact the reference that you're working with. So you can see here they are the same. So then we can switch and we can handle the messages we want. So in this case, the very first message is something that we're not necessarily interested in. So in the default case, I'm just going to output it. And we'll run that. Whoops. Run that through. Okay, and then the next one that we get is going to be the ref message change. Okay, so you can see that there. So in order to test this fully, I'm going to go ahead and I'm going to turn or disable that breakpoint and just continue to run. Okay, so you can see all the ref messages changed just from trying to scale this thing. Okay, so let's unselect it now. And you're going to see the callback go into the selection set changed. Okay, so you remember that from yesterday we talked about selection set changed is really just a virtual of the utility class. Okay, so it's part of utility object and we're implementing it, and what happens is 3ds Max will call that virtual whenever it's changed. Alright, so we'll go back down here and take a look at the selection set changed. So here we basically are checking to see again if something is selected, do a replace reference on that selected node, and if nothing is selected then we'll go ahead and replace the reference to null. Alright, so let's run that and you'll see these things are being called again. So what I'm going to do is I'm going to go ahead and I'm going to turn off those breakpoints as well. We no longer really need to see those. Okay, so as soon as we select it again, we get our selection set changed, and we're going to replace reference, and now we're referencing it again. So one trick I want to show real quick is that MaxScript can actually help you with some of this testing. So for example, we've got this node selected and we want to maybe test to see if we can capture the wireframe color change. So what I can do is, instead of trying to do it through the UI and changing the context of the plugin itself, I can just come over to MaxScript, and within the utility object's context I can make the change. So I can say wire color equals color, and I'm going to make it blue. Okay, so the $ represents the selection, so it's the current node, and the wire color is the property that I'm going to change. So I hit that. Oh, there it goes. And you'll see, okay, now I got the reference message node wire color change event. So it worked. So the last thing I wanted to show in the example code was the broadcast notification example. So, you know, one of the issues is we use the selection set changed callback. And so normally the reference system can notify you when a node has been deleted. But in the logic of our code, we were basically saying as soon as the node leaves the selection set, so it's no longer in the selection set, we replace our reference to null. So that means we no longer have an actual reference to it. So in the events, the sequence that occurs, the node is removed from the selection set and then deleted. And so therefore we can't use this same reference system mechanism just because we decided to use the selection set changed. So that gives us an opportunity to use the broadcast notification system. So in order to set that up, what we need to do is we need to have a notify proc, and you'll see that that's a static, and that's the main thing that we have to implement. We also have to register for the notification. So you'll see here in the begin edit params, I registered for the scene pre-delete node notification. All right, and then I passed in my notify proc, and so this is the address of the procedure, and because it's static, it's okay to do it this way. All right, and then in the end edit params, we unregister it. All right, and let's go take a look at the notify proc itself. So the notify proc basically looks at the info to make sure the code is what we want to check for, and this would be used in the case that you have multiple messages with one notification proc. And then we're in a circumstance where the node is still alive for us, so we still have the reference to it. It hasn't left the reference system yet, and so we can check the info coming in and look at its call param to see what's calling us, and that will be, in this case, the node itself that's being pre-deleted. All right, so we can just double check to make sure the node that's calling us for the pre-delete is the one that we've got a reference to. Okay, and so let's just switch over and go ahead and run that. So I'm going to say delete. Now what you're going to see is the selection set changed is hit first, because the node has now been, it's starting to be deleted, and therefore it's being removed from the system. And you can see the notify proc is being hit, and our node is actually still there, and so therefore we can put up the message at that point. All right. So after the notify message is posted, then the set reference is called, and that's when the node becomes nulled. All right. So that helps us out in this particular circumstance. So the point around this whole exercise was not only to show you the reference system and the broadcast notification system, but to show how in different circumstances they can be used together, and one might provide a benefit over the other. Okay, here we go with Module 5 then. So today we're talking about parameter blocks and function publishing. The goal is to give you the structure of the parameter blocks and how you can build your own. And we'll also talk about the UI aspects and how the parameter blocks tie in with the user interface. And then we'll move into function publishing, and we'll show some examples of how that connects with MaxScript. So the responsibilities of a parameter block are basically to store the parameters of a plugin. So for example, if you are the geosphere, you would have a parameter block that contains all the data, such as the radius of the sphere, its type of sphere, and any other characteristics that are unique to the geometry, to any aspect. So the parameter block will also expose those values to the user. So this is the tie to the user interface, as well as you get some automatic publishing to things like MaxScript. Also handling the interpolating of values via a controller, so this goes back to the animation aspects. And then the loading and saving of the data, so they say variables, but that's really the parameters. Displaying animated values in the track view. So not only do you get the user interface aspects in the rollout panels, but the track view also shows those things. And then again, exposing variables to MaxScript. So parameter blocks are implemented as an object of class iParamBlock2. You remember we talked about some other types of parameter blocks that are the older types, and you're going to run into those as you're working with some of the existing objects. But when you are working with a new plugin, you're going to use iParamBlock2. When the parameter block is constructed, you're going to specify the number of parameters, the types of those parameters, and any associated UI controls. So this is done through a parameter block descriptor, and the parameters may be animated or constant, but if you're going to make them animated, there needs to be a controller assigned to it as well. So to talk about the UI aspect, a parameter block can correspond to a rollout window, and that's the basis of it. Contains UI elements or widgets that correspond to particular parameters. So you'll use the p_auto_UI flag to use a parameter map. Okay, so this is basically the flag that says, okay, let's map it to the user interface. So here's a quick example screen cap. You can see, the rollout panel parameters are here. In this case, there's radius and segments. the hemisphere, chop or squash, and you can see that transfers over to the track view as well, and the same parameters are listed here. Okay. So to create a parameter block, you're going to use these param block descriptors. There's two ways to actually get them constructed. The first is to call make auto param blocks, or there's a global function called create parameter block 2. So you have to describe a parameter block. So there's basically one parameter block descriptor for every parameter block. And within a parameter block there can be multiple parameters. And then you're going to create a singleton parameter block descriptor that remains valid throughout the life of the plugin, or the DLL. And this is done by declaring a static instance. Okay. The parameter block descriptor is going to take a variable amount of arguments that describe the parameter block. There's 5 arguments that are required, and then for each parameter that you want the user interface control, you're going to supply some other mandatory and optional arguments. Okay, so let's take a quick look at some sample code. So I used the plugin wizard to create this. So here's an enum that describes the parameter block itself. So this is the P1 params. Here's the enum that describes the parameter. So typically this enum would have multiple entries if there were multiple parameters. And then here's the parameter block descriptor 2. Okay, and we will look at this in detail in a minute, but I just want to show you real quickly how it's formed, so when we start talking about these terms in the presentation, you'll kind of understand what it looks like. So it's a static, it's param block 2 descriptor, and then this the name. Okay, and within this descriptor is the name of the parameter block. We give it a string, so this is called params. So that's 1, 2, and then the third argument is optional. We need to give it the class description. Okay, so this is the the class description that we've seen throughout the presentation. So that's 1, 2, 3, 4, and then we need to tell it what type of construction and whether or not it's going to be mapped to a user interface. So this is number 5. Okay, so we have p auto construct, which means auto construct a parameter block, and we are going to associate it to some user interface. All right, and this is the reference. It does use the reference system to create a link to the parameter block. And then here comes the UI. So it's associated with the panel that was created in the resources. Okay, so you can see there's the IDD panel. There's a string that describes the parameters. There's some optional arguments here, and those are pretty much all null, 0, 0, and null. And then here's the parameter itself. And you see it's using that enumeration to define it. Here's the textual version of it. What is its type? It's a floating point value. What's the behavior? And this could be 0, but in this case it is going to be animatable. So that means it can have keys set, and its value can change over time. And then what UI string? This is just the string that it's associated with. So typically this and this match. And then, okay, so this is going to be a spinner parameter. So what is its default value? So it's 0.1. What is its range? What can be the validity of the value itself? Well, it can be only from 0 to 1000, and so that prevents it from going negative or above 1000. And then what is the specific UI element? Well, it's going to be a spinner. It's using an edit box as well to contain the type of float. And here's the control for the edit box. And here's the control for the spinner. And this is the increment for the spinner itself. So how much does it increment as it goes up and down? And then it ends with an end block. And something I want to point out is that in 2013 they updated to make the end define be more clearly associated with 3ds Max. So we were having trouble with templates that also used a more general term for end, and so they've added the P underscore. So the wizard doesn't actually create it properly yet, and I'm going to look into fixing that. But just know that in any code that you generate using the wizard, you're going to have to add this P underscore to the front of the end that designates the end of a block. So this is the end of the parameter, and this is the end of the full descriptor. Okay? So then let's talk a little bit about the parameter block flags. So here's the list of different flags that can be used. You saw the P auto construct was in our last example, and the P auto UI. So these all fit into this, into this area. Okay, you can have multiple flags there, and all of these have different meanings. So I'm not going to read through all of the different definitions here, but you can look in the documentation and it'll tell you exactly what all of these things mean. So when we start talking about the parameter block and how the auto UI works, so automatic rollout management is handled depending on the type of plugin it is and where you need it. So these are all part of class descriptor 2, and like the begin edit params and the end edit params, that's a good example of when the parameters are entered for editing and when they're exited for editing. And then the create param dialog, there's two different forms of that, and that's how the rollouts start to be created, etc. Okay. So UI specification arguments, so you need to provide the ID of the dialog template, and then the string table resource ID of the title of the dialog. Okay, and this is what goes in the top. And like I said, typically those match the names of the parameters, but that's up to you. And then there's a flag mask that's used by the begin and end edit parameters, which will determine whether the iParamMap2 should be created or deleted on this call. Okay. And then there's a flag used to control the rollup creation. And then you can either pass null or the param_map2 user dialog proc. So basically a user dialog proc that's going to handle special processing for any controls. So you can let the system manage it, map it to the controls, or if you need real special behavior, you can provide your own dialog proc. So the parameter specification arguments are laid out here. So you need to have a param ID, which is basically the index or the position in the parameter block. You need to have the internal name for the parameter. This is provided as a Unicode string. You need to have the type of the parameter. And then you need to have a flag to tell it whether the type is one of the tab types. So tab is a 3ds Max specific table, which is like an array. Okay. The next one is another integer that provides the combination of parameter specific flag bits, and that's to again provide some really specialized functionality. And then the last integer here is the ID for a string resource, or it's the localized name for the parameter itself. And then the parameter tag, which is a list of optional tags and other values. And then finally the p underscore end. Okay, and this value is a param tag that indicates it's the end of the parameter specification. And again, prior to 2013, this was simply end, END, and with 2013 they changed it to p underscore end. So there's two different parameter types. So there's the param type or the param type 2 in the enumeration, and they're basically enums, so they kind of merge together anyways. So these are all defined in the header file param type, and let's just take a quick look at the documentation for this. So these are all the different types of parameters. So the param types are identified by either param type or param type 2. And like I said, they're defined in that param type.h. And because they are simple enums, they merge together, so you just need to specify the name. So type float, for example, is a single floating point value. You can see all the types are identified here. There's a point 4, there's angle, there's world, which is a parameter that represents world distance units, strings, file names, and you can see this list is pretty extensive. So it's basically all of the 3ds Max types that are understood by the system. The parameter flags is used in the parameter specification as well, and here's a quick list of all of those flags. I'm going to go to the docs again, and here you can see there's things like can the parameter be animated? Is the parameter transient? Is it a sub-animatable? Is it invisible? Okay, prevents the animatable parameter from being shown in the track view, for example. So there's quite a few flags here as well. And then finally the parameter tags, and these are optional tags that are provided in the enumeration param tags, and let's take a quick look at those. So here the parameter tags are used basically to specify different ways the parameter can be used. So for example, p underscore UI, this is a user interface control specification. P underscore range, we saw that in the example, it specifies the upper and lower limits. So there's quite a few, basically I call them, modifiers that specify the specific behavior of the parameter. So when we start talking about the UI, if the optional p underscore UI tag is included in a parameter block, then it is followed by the user interface control specification. So this is very specific to the type of control. So for example, there's the spinner, a slider, radio button, single checkbox, a check button, and it just goes on to kind of mirror all of the different controls that are used, that can be used in 3ds Max. Okay, there's even things like the point 3 list box, which is kind of a unique thing to 3ds Max. And then even more specifics to the controls. Let's just take a quick look at these. So for example, we're going to look at spinner and slider control types. So here's some further details. So for example, you can make the edit type an int, a float. Universe has to do with the value in world space units. So for example, feet and inches or meters, whatever your unit is. And you can see that there's things like position and time value, all these things. The list box also has some qualifiers. So here you have time value, int table, angle table, and so forth. And then finally with combo boxes, same idea. The combo box, here's an example of a combo box. So you have the different qualifiers to set it up. All right. So the great thing about parameter blocks is that saving, loading, and deleting are all done automatically. So a param block is a reference target, and so this falls into the reference system that we talked about yesterday, and therefore, the saving and loading are handled. So any objects that are implementing param blocks will be automatically a reference maker. And there's really nothing for you to worry about. As long as you implement them correctly, the system is going to take care of saving, loading, and deleting. So working with the parameter blocks to get and set values. So parameter block values are set from the iParamBlock2 object using the param ID. So it's basically the index into the parameter block. So don't confuse it with the old system where it's just a simple index. So really in this case it is a unique param ID for that parameter block. Okay, it's used in an enumeration. It's used from an enumeration to positively identify that parameter value. So also an interval reference is supplied, and this can be used across multiple parameters to determine the validity interval. And we're going to talk about validity intervals in the animation topic next week. So to access and expose parameter blocks, you first of all have to inherit from animatable, and as we've seen in the earlier presentations, basically everything derives from animatable, so that's not an issue. And then you need to implement the number of parameter blocks, the get param block by ID, and the get param block. So just to remember that there is the older parameter block. So it's deprecated, but we have to maintain it for legacy. So as you've probably seen already in the C++ sample code, the SDK sample code, there's many forms of the older parameter block and the iParam array. But the idea here is that when going forward, the plugin wizard will create iParamBlock2, and if you're creating any new plugins, even if you're using the sample code from an existing plugin and it's using ParamBlock1, I encourage you to update it to iParamBlock2. Okay, just so you don't have any trouble. iParamBlock2 is much more efficient, it's easier to use. It's the current way of building parameter blocks. So I'm not going to go into a lot of details with these advanced parameter block topics, but I want to make you aware that you can have multiple parameter blocks. So you can have more than one if desired. All the parameter blocks should be associated with the same class descriptor. Okay, so a plugin has a single class descriptor, and if you have multiple parameter blocks, it should be associated with that one. And then monitoring parameter changes, there's this PB accessor class that you can override, and you can monitor parameter changes using a callback mechanism. So this is slightly different than using the reference system. Okay, so it's specific to parameter blocks. And then subtexture map parameters. This is something that you should use this only if you were upgrading a plugin. Okay, so if you have an existing subtexture map plugin, something that's using a subtexture map, use this information only in that upgrade status. Okay, I'm not going to go into those details. Using multiple rollups, there is a flag called p_multimap, and this will allow you to have more than one rollup associated with parameters. Okay, so this is how you can modify your user interface based on the different contexts that your plugin might be running in. And this leads us to looking at some sample code. Okay, so let me switch over here to Visual Studio, and I have a file open that's from the Expose Transform sample, which is also a feature. It's a helper object within 3ds Max. And the first thing I want to point out is that here's the param block descriptor 2, and the class descriptor that's being passed in is Expose Transform descriptor. Now this has several parameter blocks in it, and you'll see that in each case it's always associated with the same class descriptor. Alright, so that's one important notion of the parameter blocks, again, is that you should associate multiple parameter blocks with one class description. So also you can see here that this parameter block, this particular one doesn't have any user interface assigned to it. So these are just parameters that are being stored. This next one, this parameter block, is it this one? Yes. So this one is going to have a UI. And so you'll see down here as the parameters are defined, there's different UI types assigned to it. So the PUI is pick node button, single checkbox, etc. Alright, so if we switch over to 3ds Max and we go into the helpers, here's the Expose Transform, and here's the different UI elements that are constructed by this parameter block. So for example, Expose Node is right here. So this is the internal name, and then this is the UI name. Okay, so that's a resource string. The local reference node, that's this string here, and you can see it's a pick button right here. So that's the pick button assigned to it. Alright, so that's kind of how it's mapped to the user interface. So let's take a look at a different one now. Here's the param block descriptor for GeoSphere. So I'm going to switch back over here, and I'm going to go to, let's see here, the GeoSphere is here. Okay, so in GeoSphere, there is 3 different parameter blocks as well. And again, you'll see it's the same class descriptor being associated with it. And in this case, because it's an object, there is a creation version of the parameter block, and this is for this during the creation phase. Okay, those are the parameters during the creation phase. And then there's a separate one for the type in, or for the keyboard entry. Okay, and you'll see here is the type in position, and it's using an edit type universe, and it's got, you know, X, Y, and Z values just like this. Okay, so this is the map for the key in entries. And then finally there's the parameter block for the parameters that are going to live with the object after it's created. So let me create one of these. Okay, and then I'm going to go to the Modify tab, and here's the parameters that actually live with the instance. Okay, and in this case, for example, there's the hemisphere checkbox. Okay, and these are not in order of the parameters themselves, but they're defined by the panel. I'm sorry, that's not the right panel, but these are associated with the IDD GeoSphere 2 panel. Okay, so there's the hemisphere, segments, radius, base type, base to pivot, smooth, and mapping coordinates. Okay. Now the interesting thing here is that these are also the same parameters are showing up in the track view. Okay. So for example, the radius. So here's the radius. I can go over here to the track view and I could add some animation here. Okay. So when I go through and run my animation, you'll see the sphere's radius is pumping in and out. And you see over here now that radius parameter is animated. Okay. And that's all associated with this parameter called radius being animatable. Okay, so it's all tied together, and this parameter block is what is the basis for how the user interface works and how the parameter is stored and how it's animated and the controllers associated with it. Okay, so that brings us into the next topic, which is function publishing. So both parameter blocks and function publishing, we could probably spend an entire day talking about these topics. So at first I thought, well, I'm going to leave function publishing out, but I think it is a very important topic. I really like how when you've published things, the Max script is automatically given access to things. Of course, function publishing is more generic in the sense that you're able to publish your functions to outside users. It means that another C++ plugin could come along and execute your functions without you having to go through providing an export lib to the other person, etc. It provides an independent means for you to publish essentially an API from your plugin to allow others to work with it. So again, it is accessible directly through MaxScript, and again between separate DLL plugins. And the idea is that it's similar to COM style publishing, but it's 3ds Max specific. So it uses the same ideas as COM, but it's implemented internally with 3ds Max. Some purposes would be to modularize your large plugin code base. So even within your own code, you might have multiple plugins that you load and unload and use function publishing to call within. So it could allow you to modularize, make things simpler, smaller memory footprints, etc. It also provides this automatic scripting ability. So again, it does push out to the Max script. Invoking plugin functions within the UI. So there's this this manipulator system. It's not so new anymore, but that is one way to give it access. And then there's also the idea of scripted menus and the quad menus and other UI elements. And there is a bridge to COM. So if you really wanted to publish everything through COM, once you have it published in the function publishing system, you just add one more layer to get it to COM. So the first question you have to ask yourself is what to publish. So you might publish important algorithms within the plugin, functions that work with the state of objects in the scene, or UI action functions. So to do function publishing, there's basically two components. There's a function descriptor system, which allows you to declare the function with descriptive data. And this is very similar to the parameter block idea that we just looked at. So you have to describe how your function is going to be called. And it uses similar types, like if the function is going to take a parameter of integer, you're going to use the type _int to describe that. And then it provides a function calling mechanism. So this would be used by the client to call into the published functions. There's also an interface structure, so functions that are published through the interfaces are available and easily accessible to outside. Each interface is represented by this instance of a class derived from the base class FP interface. So this is what gives you the fundamental functionality to call the functions between separate plugins, for example. And this is all provided in the single header file ifnpub.h. So it's the interface function publishing system. So the interface structure is basically you need to identify it uniquely by an interface ID. And this is very similar to a class ID, it's just got a different type associated with it. And the definition itself is bounded by a map. So there's a begin function and an end function, and those are macros that will then generate the actual code that allows us to work. And then within the map itself, there are macros defined that provide you with the ability to publish functions of certain number of arguments and whether or not the function returns void or some type. So here's a quick example of your public interface. So this is what you would create in a separate header file, and this is what you would hand out to another plugin to be able to call into yours. Or this is what you would use to share your interfaces in different DLLs within your own product. So the first thing you do is define the interface, and then you would typically define some way to access the interface. So this is just saying, okay, this thing called get em faceops interface is really get the function publishing interface defined here from its class descriptor and return it as the type that it's really defined as. Okay. And then again, there's enumerations that define the position of the function within the interface, and then the class defining the interface itself. So this class em faceops is derived off of fp static interface, and then you define the virtual functions that are going to be callable. So an example for calling these, so if you were to include that header file in your plugin, you would start with an em faceops pointer, and you would get the em faceops interface, okay, by passing in the class descriptor. And then off of that you could call one of its functions directly. Okay, so calling the function directly. There's the em faceops, there's the interface. So indirectly you can use some types that we also define in the function publishing interface. So you could say, okay, I want the function publishing params p. It's going to be 3 arguments. Well, the first one is type mesh. The second one is a bit array for faces array. And the third one is the type float. So you define that first. And then you set up a value to receive the result. So this is a published value. And then you go to the FP interface and you use the class descriptor, get the FP interface called faceops, and then you can use the interface to invoke the method called em extrude. There's the result where it's going to be stored, and then here's the parameter list that you're passing in. Okay, and then at the end the result's going to come back and it's going to have the values stored in it. Now if we were to go from MaxScript, it's a little bit different, but it's similar. So the faceops here is the interface name, and it has a function called extrude, and again it's going to take the mesh, so that's this, the object called foo's mesh, and then the bit array of the faces. So here's an array of the faces, and then again here's the float type. So what does the implementation look like? What is the hidden detail? So here's where the function map comes in. So first of all, there's our public class. So if we go back up here to this slide, here's em faceops. That's our public class. And we derive an imp class off of it. And then we need to declare the descriptor for it. And then we begin the function map. And the first function is the delete. So there's the enum for delete. It's a function that takes 2 arguments and has a return type. Okay? So the first thing is the return. So it's going to return the type of int. Okay? The next thing is the name. It's delete, or I should say the function itself. and then it's taking two arguments, the type mesh and the bit array. The next one is the extrude, and this is what's called a void function. So this is a return type function, and this is a void function. In this case, the extrude is taking three arguments. So for a void function, we now have the enum defining the extrude. We no longer need a return type, so this argument is missing, and that's why there's two separate macros. So we go directly to the name of the function and then the type of the arguments. Okay, and then we end the function map, and this is going to build the code that the interface can call. And then we need to implement the actual functionality. Okay, so this is where the delete and the extrude would be implemented on the code side. And then we need to provide a function map for it. And this is what looks very similar to how parameter blocks work. So here we have the interface, and what is the interface name? It's called faceops, and here's the string resource, and here's the class descriptor. And then we define the function itself. There's the em delete, and again it's associated like here, so they have to match up. It's called delete. There's the localizable string, and it's returning a type of int. And then the parameters that come in is the mesh, okay, and the faces. And then the same for the extrude. It's called extrude. It's a type void. And then it's taking the mesh, the faces, and the floating point value for the amount. Okay. So this is built out with some different arguments. So for example, here's the index or the enum, the name, the localizable string, the type that it's returning, and then there's another parameter here, but the important one out here is how many parameters are used in the function. So in this case it's 2, 1, 2, and in this case it's 3, 1, 2, 3. Okay, so those numbers need to match these macros. All right? And then to complicate it even more, there's a mixin interface. So this is called the function publishing or FP mixin interface, and it's a variant of the FP interface, and it allows multiple inheritance, and this allows you to publish on any arbitrary class. And there's some other topics, and like I said, we don't have enough time to really cover this in huge detail, but I just want to point out that there's also this thing called the action interfaces, and these would contain only UI action functions, and that goes back to that customize dialogue and those actions that show up in that list. And then it provides a programmatic way to drive the UI. So you could actually expose all of the buttons or the different aspects of your user interface to these actions, and then someone could script it as if you were pressing the buttons. There's also the notion of parameter validation. So there's a facility that provides a whole bunch of ways that you can do validation. There's also exception handling. So you can use exception handling to report errors back to the caller. And then there's separate property accessors for MaxScript. So if you want your MaxScript users to be able to use things as if they're properties as a MaxScript property, you can expose them in a special way to make sure that they're used as properties. And that leads us to the exercise, but I want to show some sample code first. So let me switch over and look at some sample code. Okay, so some quick sample code here. So what we're doing is we're exposing a static interface that can operate on something within my plugin. And this is a static interface that you can just call from anywhere and it will work and provide you with some additional functionality. So the first thing that we need to do is we need to provide the function publishing interface, and I'm using the FP static interface, and I'm creating a class that's called FP interface exercise 05, and you can guess that this is the exercise for today. So I'm just going to show the code as an example and then let you take a shot at coding it, and of course I will provide the solved version as well. So the first thing we need to do is we need to create a separate header file. In this isn't absolutely necessary, but in concept it's the right thing to do, because if this was ever needed to be called from another plugin, that plugin would need the header. And because this is just an interface class, there doesn't need to be any other definitions. The header file is enough. So we include the function publishing APIs, and we define an FP interface ID for this class. Okay, so I use the class generator, so this tool here, the GenCID, to create a new class for the interface ID. So you need to change it from class ID to interface ID, but it's the same type of format. So I generated a unique ID for my interface ID. And then I've defined, and this again isn't absolutely necessary, but for completion, conceptual reasons, you should define this so that the caller can just say get exercise 05 function pointer interface, and it's going to give them the interface without having to go through this extra casting. So it's just a convenience thing. And then here's my enum, and I have one parameter, and it's just going to be index 0. And then my class is basically this, and my function is going to be update main params, and you can see it's a virtual that is abstract and has no implementation. Okay, so this is my interface. And then within the code itself, I need to implement this. So the first thing I do is I create an implementation off of that public class. There's my declared descriptor, okay? And then I begin my function map, and this is going to be a void function with 3 arguments. This is the identifier. This is the name of the function itself. So this and this need to match. And then what type is it? Well, it's going to be it's going to take a parameter of type material, it's going to take a parameter of type float, and it's going to take a parameter of type int. Okay? And then within the function itself, it's going to take that material, the float value, and the integer value, and it's going to call into the internal code and call this function called update main params base. Okay? So the material is something that is from the exercise. And then finally, we're going to do the exercise, the class descriptor. Okay, so here's the name of the class, and then here's my function map. And within this, I need to give it the interface. And what's the name of the interface going to be called? It's going to be called EX05. And this is going to be a core interface. Okay, so it's not associated with any plugin class directly. Okay, and here's my my identifier, and there's my the function itself, and it's returning void, and it has 3 arguments. So the arguments are the material, the float, and the integer. Okay, and then there's the end of the function map. So again, this is the function map description for the class. Alright, so that brings us to the exercise. So for the exercise, of course, I want you to work with parameter blocks and also function publishing. So what you're going to do is, first of all, use the wizard to create a plugin that is a materials type. Okay, this is going to create a new plugin derived from the MTL base class. So the nice thing about this is it builds some parameter blocks for you. So what I want you to do first of all is review that parameter block implementation. So this is the material skeleton, and it provides a spinner parameter that is type float, and then you can look at the other parameters and see how that works. At this point, you could build it and run it and just see those default parameters in the material editor. So then the next thing you're going to do is add a new integer parameter to the parameter block in the material. So this is going to be adding to the parameter descriptor. Make sure that it can be handled by the UI with a spinner control, and it is stored with the material. So it's almost identical to the floating point value that's there, but I want you to make it an integer this time. Alright, so you can use the floating point one as an example. And so once you have that working, then you can use function publishing to add a core interface function that's going to be published. And in this case, the function is going to set both the spin parameter and this new integer value that was added above. So you're going to use function publishing to drive the values on this material. So it should be pretty straightforward to get this going. And again, in the video I showed the function publishing example for the exercise already. And let me know if you have any problems or you had any questions about today's presentation. And thank you for your attendance. Of course, we'll go over this exercise on Monday and show all the details of how it works. And it's Friday, so I'd like to say happy weekend. Have a good weekend, and we'll see you back here at the same time on Monday. Thanks again.